Okay guys, so in this question we have a question that says US postal regulations state that the sum of the length and the girth is the distance around the box, this distance right here, of a package must be no more than 200 centimeters. Find the dimensions of the package that has the largest volume if the end of the box is a square. The end of the box they're talking about is this end right here. This has to be a square. Now if you don't tell you that this is a square and all they tell you is that the length plus the girth are equal to 200, you'll have many different numbers that you can plug in for the length and the width and the height, and it will be an endless trial and error type of question. So you'll have to enter a value for the length, then assume a value for the width and then for the height. So you'll have to assume many different values that will add up to 200, in which case it will take you forever to find the largest volume. That's why we have to give one more piece of information, which is that the end of the box right here is a square, in which case the width and the height will end up equaling to each other. So we're going to have to assume that the end of the box is a square. First, let's just start writing an equation for the length and the girth. The length plus the girth together should equal to 200 centimeters. That's the length, which is the distance from here to here. And then the girth is the distance around the box. So this distance plus this all the way back to where we started. That's the girth of the box. So now with this information, which is the length and the girth, the total equals to 200, prepare the table right here, which shows that the length plus the girth are always equal to 200. No matter what the length or the girth are, together they're 200. In this case, what we're going to do is we're going to assume values for the length, which is this length right here. So this length, which we're going to call L. Let's just fix that. So we have a length here that's L. That's from this end to this end right here. And we have a width that is W, and we have a height that is H. Now because the end of this box is a square, the W, the width, and the height are equal to each other. So instead of writing H here, I'm going to cross that out, I'm going to write W. So let's assume values for the length. Let's assume a value for the length of 10. And since the girth is 200, 200 minus 10 is 190. So the girth is 190. Now half the girth, which is only from this end to this end plus the top to bottom, that's half of the girth. Divide 190 by 2. So dividing the girth by 2 gives us 95. And then half of this 95 will be 47.5 for the width and 47.5 for the height. So in this case, just for the first example here, we have a length of 10. We have a width. Let me just get rid of this and get rid of this. So since now we know that the height is equal to the width, we have a width of 47.5, and we have a height, which is also the width, that's also 47.5. So in this case, we have a length of 10, a width of 47.5, and a height of also 47.5. When we multiply these three, we get the volume. So the volume for the first one is 10 times 47.5 times 47.5. And together, let me just erase this because we don't have enough space. But if you multiply 10 times 47.5 times 47.5, you get an answer of 22,562.50. This is always centimeters cubed. So that's the volume, 22,562.50. Now, if we go to the second example or second assumption, which is that the length is now, instead of 10, we assume that it's 20. 200 minus 20, which is the length, will give us the girth, which is 180. And then half of the girth, again, half of the girth, 180 divided by 2 is 90. And then half of 90, because this whole thing here is 90. 90 is only from here to here, from left to right, and then from top to bottom. That's 90. And half of that will give us just one of the widths, the width this way or the width this way. Let me just write that down. There's a width here. So half of 90 is 45. 45 goes here and 45 goes here. Finding the volume, we'll do 20 times 45 times 45. And that will give us a volume of 40,500 exactly. Now let's continue. I'm going to go a little bit faster here so we don't waste time. Let's assume if the lengths are 30, then we're going to assume 40, 50, 60, 70. Actually, after the 60, I'm going to leave it empty for a little bit. And I'm gonna write down here 65. I'll explain why in a little bit. I'm gonna write 65, then 66.5, and then 66.666. Then we're gonna jump on to, this is wrong, let me erase this. We're gonna assume here 67, 68, and then put 70, 80, 90, and 100. The reason I stopped at 100 is because if I continue to 110, I'm going to end up with a 90 here, which is exactly the same as this one right here. So we're doing the same thing twice. So I'm going to assume I'm going to stop at 100 and then forget about the rest. Now let's go back. Oops. Let's go back to the top here and continue. 200 minus 30 is 170. And 170 divided by 2, so half of 170 is 85. And 85 divided by 2 is 42.5. That goes here. And the other 42.5 goes here. Multiplying length times width times height, we get a volume of 54,187.50. I'm going to continue. 200 minus 40. This 200 minus 40 is 160. If we continue this way, we end up with 200 minus 50 is 150. 200 minus 60 is 140. 200 minus 65 is 135. This one will give us 200 minus 66.5 is 133.5. And then 66.666 gives us 133.333. And you'll see again, like I said, I'll show you at the end why I picked this number right here. So continuing with this same pattern, half of 160 is 80, half of 150 is 75, half of 140 70, half of 135 is 67.5, half of 133.5 is 66.75, half of 133.33 is 66.66. And then here, let's continue all the way down. 200 minus 67 is 133. 200 minus 68 is 132. Minus 70 is 130. 200 minus 80 is 120. 110, and then 100. Now let's fill in all the blanks here. The width, again, remember guys, the width is half of 80 because the width and the height, remember the width and the height happen to be the same because the height is no longer height. We're going to call it the width because it's a square. The end here is a square. This end right here is a square, which I put right over here. So 80 divided by 2 is 40. That goes here, and then 40 and 40. The volume is length times width times height, which is 40 times 40 times 40, and that gives us 64,000. Again here, continuing, 75 divided by 2 is 37.5, and 37.5, 37.5. And the volume, if you multiply them, you get 70,312.50. Next, 70 divided by 2 is 35. So we have 35 here and here. 60 times 35 times 35 is 73,500. 65 here, we have 67.5 divided by 2. That gives us 33.75. So we write 33.75. Multiplying 65 by 33.75 by 33.75, we end up with 74,039.06. 66.75 divided by 2 is 33.375. That goes here and here. Multiplying 66.5 times 33.375 times 33.375, that gives us 74,073.73. And at 66.6, we end up with 66.6 here divided by 2 is 33.333. So 33.33. And same thing here, 33.33. Now if you multiply 66.666 times 33.3 continued and 33.3 as well, we end up with a volume of 74,074.07 centimeters cubed. Continuing, we have the half the girth, so half of the girth, which is 133, that's 33, no, that's 66.5, and then half of that is 33.25. That goes here and here. And then when you multiply 67 by 33.25 times 33.25, we end up with 74,072.69. So if you guys notice, the volume increases from 22,000 to 40 to 54 to 64. It keeps increasing all the way till we get to this point right here, which is 74,074. And then it starts to decrease again. It goes down to 74,072. So our maximum volume happens when the length is 66.6. The width and the height are 33.33 each. And we're going to show you at the end how to do this algebraically. But let's continue with this table to show that the volumes here are all less than 74,000. So when the length is 68 and the girth is 132, half of 132 is 66, and half of that is 33. So 33 goes here and 33 goes here. Multiplying 68 by 33 by 33, we get 74,052 exactly. Half of 130 is 65, so we put a 65 here, and half of 65 is 32.5. So we have 32.5 here and 32.5 right here. Multiplying 70 times 32.5 times 32.5, we end up with 73,000 and 937.5 or 0.50. You see how the volume is now decreasing. Let me fill up the last three columns, last three rows rather, quickly. So at 80 we have 120 divided by 2 is 60. Half of 60 is 30 and 30. When we multiply 80 by 30 by 30, we end up with 72,000. So that's a lesser volume. At 90 we have a girth of 110. Half of 110 is 55, and half of 55 is 27.5 and 27.5. So 90 times 30, 27.5 times 27.5 is 68,062.50. And finally at 100 and 100, half of 100 is 50, half of 50 is 25. So 100 times 25 times 25 is 62,500. So if we examine this table, if you go up here, you'll see that the maximum volume happens at 66.6 for the length. So we're going to go up here. We're going to copy this guy. Let's copy this and duplicate, bring it down. So here from this table, we see that the maximum volume happens when the length is 66.6. So this length right here is 66.6, or let's just round it off to 66.67 and forget the line on top. So 66.67 for the length, and the height and the width are 33.33 each. If we notice here, they're 33.33 for the width and the height. So this is 33.33 and this is 33.33. Now, how do we do this algebraically? Let's go back to the beginning where we said, just 1 second. So we have a length plus a girth that together are equal to 200. The length, we're going to keep it as L. And for the girth, because this is W, the width is W, and the height is also the same, which is W, since it's a square, we're going to write length plus W, which is the base and the height, but times 2, because it's a full rectangle, which is a square in this case. So plus, let me just erase this, plus 2W for the top and the bottom. This top right here, the top and the bottom, that's 2W, plus another 2W for the left and the right side of this box, or of the rectangle. So we have length plus 2W is equal to 200. If we simplify this, we get L plus 4W is equal to 200. Now let's solve for L. We get L is equal to 200 minus 4W. Now the volume of a box, or of a complete rectangular prism, the whole rectangular prism, the volume is length times width times the height, which in this case the length is 200 minus 4W. 200 minus 4W, that's for the length, times the width, which we're going to keep in terms of W, times the height, which is now also W. This simplifies to volume equals to 200 minus 4W times w is w squared. So times w squared. And if we expand and multiply w squared by these two terms, we end up with the volume equals to 200 w squared minus 4 w cubed, which I'm going to write in standard form as negative 4 w cubed plus 200 w squared. Now this is the volume that we're trying to maximize, and in order to maximize this volume, we can use calculus, but you guys haven't learned calculus yet, so we're going to graph this equation. Now if we graph this on Desmos or any graphing calculator, you can see that the maximum volume happens right over here, which is at w, when the value of w is equal to 33.33. So here we have w equals to 33.33, and we can see that the volume is 74,074.074, which is exactly what we got up here, which is the maximum volume that we got up here, 74,074. So going back to this, when you graph this, you can see that the maximum volume happens when the value of w is 33.33 centimeters. So if we look at the table here, this here is the width, which is 33.33, and since the height is also equal to the width, since it's a square, the height is also 33.33. This means that the length is 66.66. And by the way, the way we can get 66.66 is because if you go here to this equation and we solve for L, we can solve for L by doing length is equal to 200 minus 4 times 33.33, which is equal to 200 minus, what's 4 times 33.33? That's 66. That's 133.33, if I'm not mistaken. I'm going to use a calculator, even though I'm quite sure that this is the answer. So 4 times 33.33, that's 133.33, exactly. And then 200 minus 133.33 is 66.6 continued, so 66.67. So we can see that the length is 66.66 or 66.67. The girth happens to be 133.33, and the volume is 74,074 centimeters cubed. And that is your answer.